Yeah, welcome to the talk. Thanks for joining in the session. It's been great for the last 2 days. Lots of talks on DevSecOps, purple teams. I really love all of the sessions. I'm a I'm a big fan of DevSecOps culture, so I really loved all of the sessions. Before we start this, I want to kick off with an analogy, right? So imagine you are tasked with saving Titanic, right? I'm sure all of you would agree you'll not be writing a strong email to the iceberg or the captain to with a list of recommendations to stop it, right? You would probably want to create a secure path for the ship to sail through and stop bad things from happening. That's really kind of the essence of this talk, to create a secure security paved pathway when you have web applications accepting file uploads. So with that, a little bit about myself. I know he said 8 years. That was written a couple of years back. But I've been doing software development, mostly developing security products. And over the past few years, I've focused on product security. I really like building things. I know a lot of people like breaking things, but I like building stuff. And I really like to invent, and you could see a lot of inventions there. I believe inventions are core to kind of help cyber take it to the next level. I've heard earlier career attempts. I tried playing soccer, didn't go well, but I'm not complaining. I really like this career. I'm very passionate about InfoSec. And that's one of the reasons I kind of go around the globe, talk in conferences, and contribute in a way I can to the community. For the agenda today, we are going to talk about the current trends in file-based attacks. And then just to set the stage, I'm going to talk about different malware processing techniques, what they are. And then we'll take a look at some of the recent attacks to kind of give an idea of where the threat vectors are. And then I'll go on to talk about the architecture of file upload, how you can design a secure pathway. And just a bit of the introduction on the topic, right? I just want to convey that this is an independent research, and this talk will not be targeted at any vendor. It's a vendor neutral talk, and the mileage can vary in your organization. So I'm going to talk about different techniques, different architecture, and about scalability, but you should take it with a pinch of salt. This is just a descriptive approach I'm going to propose. It's not a prescriptive approach, so I'd like you to take it at that. And a disclaimer before I go in, just so I keep my legal team happy. This is nothing related to whatever I do at Visa, the current posture or the future. So please take it that way. All right, so let's jump into file-based attack trends, right? So if you look at this chart, this is from the Verizon data breach report. So in 2016, if you look at the web-based attacks, it was about, I think about 15%, and it has jumped, or maybe 17, and it has jumped 6% from 2018. So what it means is attackers are trying to send malware through web. Earlier, the most popular delivery method was email, but it's shifting rapidly. And also, if you see on the right, Office dock is becoming a very popular way to deliver the malware. So let's kind of zoom in on that and talk about what it means, right? So when you think about malware, typically you think of an executable that comes into your environment. It gets downloaded in your system, and then it runs a set of programs. Maybe it talks to the command and control server, sends your data out, whatnot, right? But the new trend is fileless malware. So you have a file like a Word doc which carries a set of binary instructions, and it executes as part of your known application, let's say PowerShell, right? So you trust that program. There is no executable or binary, but then it gets executed as a fileless attack. Let's talk about different malware processing techniques that are available to us, right? Before we deep dive into the attacks, I'll talk about what the techniques we know of so far. So first is surface analysis. This is really kind of taking a piece of file and understanding what it is, right? It doesn't go into the details on what it does, or other details on how it gets executed. It doesn't really involve a lot of CPU cycle per se. So you just take in a file, look at it to say, hey, this is Fred, for example. It doesn't tell you anything other than that. But it's quite useful because you detect the file type, and if somebody is spoofing, right? For example, if Fred, if it's not really Fred and if it's Chuck coming in as Fred, you kind of detect and reject that. So you don't want to take a .exe file masqueraded as a .docs file. So that's what this really does. And then the traditional antivirus scan, I'm sure you're all aware of this technique. There are quite a few drawbacks with the way AV engines work. There are a lot of positive, obviously that's the reason we use it. But if you think about the completeness of detection, meaning how many files an AV engine would detect, it kind of varies across different AV engines. And it's always an opinion of what the product thinks, and is also a correlation to the kind of signatures the product has. And a lot of time the AV engines are not good at classifying the malware. So they can detect and say, hey, it looks to be malicious, I don't know which family this belongs to, right? So that is kind of the drawback, but there is a lot of good features that come with it, especially if you run multiple AV engines together. It's going to increase the completeness ratio and the correctness ratio, because now you, instead of having opinion from one expert, you're going to have opinion from different experts on the same issue or the same file, for example. And then we go into dynamic or runtime analysis. So this is where a lot of CPU cycles goes into, right? So to run a file and then see how it behaves, and then kind of extrapolate all the indicators of compromise, and then conclude on whether the file is malicious or not. So it is typically run in a sandbox. So you give a file to a sandbox, a VM, and it executes the file, looks at a bunch of indicators to decide if it's looking to be malicious or not. It's fairly accurate, but then it takes a lot of time to set up. Imagine if you have a web app accepting PDF, Word, etc. You need to have a VM that is set up with Adobe, Microsoft Word, for example, and then run the file. And also there are certain nuances to it, right? If you have a PDF reader version 19.2, that may not give you an idea of how it will execute in a different version. And also, if you run it in a PDF reader versus a writer, the results are going to be different. And sometimes the system doesn't just work. It will probably be a a pop-up that comes up and you have a screenshot of the pop-up, but there is no analysis that runs. So due to all these factors, it's very time consuming to set up, and it's also very time consuming to run a file and get a result. And when you get a result, that comes with a caveat, because you now run a file, and then you are generating result based on the run of that file, and that result can in turn have a malware. If somebody is writing a sophisticated malware, the results can in turn have infected inputs. So the next technique is a packer. So attackers usually like to obfuscate the payload. So one common way is to pack the file so that the analysis doesn't detect it's a malware. Think of it as a software program like zip or gzip. So somebody can package it and send it, and if you don't unzip the file, you're going to lose a lot of analysis metrics. A good way to kind of analyze packed files would be to first unpack it, and to unpack it you need to define several factors, right? How many recursions, if you're taking in a zip file, how many recursions do you want to allow, for example? What are the file sizes of the files that could be inside the packed file? So you would always want to unpack, right, if you're taking any packed software. And the next technique is static analysis. I'm talking about this after unpacking because that's kind of the primary factor before you could do this analysis. What it does is it looks at the PE sections or the file sections to see which sections can attribute to an indicator of compromise. So if you take a PDF file, it's going to have a header, it's going to have a section name. So based on these factors, you'll be able to generate a value that could contribute to your IOC factors. Reverse engineering, this is a complicated topic and it's very hard to automate, right? Reverse engineering is very specialized. Somebody has to manually look at the run, reverse engineer, and look at the code. So I'm not going to go into a lot of details. There are tools available like ID Pro, which you can use to do a first run, decompile it. But a lot of the sophisticated malwares are going to just bypass it because they know ID Pro, and it's very easy to obfuscate something that is not detected by your decompiler. Okay, so the last technique, this is kind of very recent and modern. There are a lot of engines available that classify based on a machine learning based algorithm. There are primarily two different types of classifiers. One, before executing a file, before the execution you can do a static analysis of the file and figure out whether the file falls into a ML classifier that is designed for a malware. And the second is on the execution, right? You let the file run, detonate it in a VM, and then see how the file behaves, and then get the labels out of the behavior, and then classify it with the ML classifier for a detection. Again, this is very premature, right? So there are lots of false positive, and there is going to be a lead time in training the classifiers to be effective. Okay, I know that's a lot of content, so I'm going to pause and ask a question, right? So we've looked at different analysis techniques. How recent do you think the analysis have to be if it has to be useful? Any quick comments, thoughts? Is 30 minutes fair enough, or if it's coming after 2 days? 24 hours? Yeah. Yeah, we'll come back to that. I'm going to talk about a few attacks, and then we'll see whether 24 hours really makes sense. So yeah, let's talk about the attacks, right? I want to talk about three different attacks. So this, you probably recognize Scarlett Johansson, right, from Avengers. Yeah. So this is an image file. So in this attack, somebody uploaded image of Scarlett Johansson, and it got stored in the database, PostgreSQL, and that database had a Metasploit module enabled. So you cannot see it in the image, but there is a binary code somewhere near the left arm, right? So basically what happened is when the payload came in and when it got stored, the Metasploit module and behind that there is Linux, and there is a software called Data Duplicator in Linux that actually extracted some of the binary components and made a call to a command and control server to download another image, which then led to data exfiltration. So the data from the database is gone. So what happened in this case was it actually evaded all of the AV scans that would typically run on endpoints or the servers, right? So that's one example. Now let's take this image file and run it through VirusTotal, see what it gives us. So if you see at the top, so this is VirusTotal result from 67 different engines that look for malicious URL, right? Only one engine out of 67 detected it's malicious, and it's at that timestamp, right? It would have changed over time. There are better signatures available in each of these engines, so it will vary. And if you look at AV engine detection for that image file, only 3 engines had a signature that detected a variant or a mutex of that file. So out of 58, only 3 AV engines are effective. So what it really tells us is AV engines are effective as long as you have the signature for it, right? So even though we throw a lot of AV engines at it, it's probably going to fail depending on the vector we are looking at. Okay, so the next one, I don't know how many of you know there is a library called ImageMagick. This is an open source library that you can include in your web app, and it allows someone to edit and create files on the fly within the web app. So this had a vulnerability in 2016. There was a very popular attack called ImageTragic, and what they did was there are a bunch of CVEs, but if you look at it, they have image files like PNG file that they run through ImageMagick, and those files had an exploit which will then impact the underlying server. So they executed a PowerShell script, did a remote command injection into the server, etc. So this is again to highlight a vulnerability through a file upload that happens at the library, right? So it's at a application level where something is exploited. So the third example, this is kind of very popular in the sense that Java scripts, right? They could be embedded in PDF, and that's one of the popular mechanisms or vehicles by which attackers like to deliver the payload. So if you have a web app, you do the baseline and you make sure you're clearing the OWASP top 10 attacks, but there are cases where web apps can have excesses, for example, right? Maybe someone did a code change and they did not check something. This type of attack can leverage that vulnerability in the application layer. So if you have a web app that is vulnerable to excesses, if you deliver a PDF with a JavaScript, that can basically reflect and execute that JavaScript and attack that web application. So I think that's pretty much it. So, and this is the main point I want to convey today, right? If you look at all the attacks we have looked at, endpoint protection or AV scanning at the server level is not really very helpful. And if you look at the traditional protection mechanisms we have, all of them either focus on server-based AV detection or laptop-based endpoint detection if a file comes through, right? So what do we do about it? So I think having a submission-based automated analysis system is a good way to take the files in. When I say a submission-based analysis system, it is pre-execution. So when the file is in the flight and it's coming through the web application, you have this automated analysis system that does a check on the file and then accepts only benign files. And we'll talk about different set of controls that come into play, right, in this sort of a submission based system. So before we architect, I think the first step would be to define the goal. So what do we want this submission-based analysis system to do? And at the core, we have to define how much it needs to tell us, right? So if someone is coming in, whether are we okay to kind of say, hey, this file or this person is Chuck, and we know Chuck is either bad or good. Is that sufficient? Or do we want to know what is his weight, what is his height, and what's his DNA result, for example, right? So that is the first step you would want to design or define based on the environment that you have and the other controls you have in the environment. And also when we start designing solution, it's important to look at the customer. We cannot just block PDFs because they have malicious URLs or embedded scripts. So it's really important to ask questions to the web applications on who the users are who upload the file, what are the formats, what are the valid business file formats the application will need, and also talk about the file size and the traffic that the application really wants. And depending on that, you would then decide what enforcement can be done on the application side. Can you enforce a particular file type whitelist, or can you enforce asynchronous versus synchronous calls? What will the user do if a file is being scanned, for example, right? And then you can also think about risky file types and see whether the application really needs them, or is there a way to kind of blacklist those type of files. Okay, so putting it together, right? So these are kind of the 8 steps in a sequence that I think would help secure a file upload. So one, the first thing before something's accepted, we would want to authenticate and authorize the user, right? Without authorizing, we don't want anyone in the internet to allow a file to be uploaded. And then number 2, there should be a set of validation or enforcement based on the surface analysis of the file. That ties back into the business case of the application to say, this application can accept X, Y, and Z, but not other type of files. And the third, always and every time unpack the file for analysis and analyze after unpacking it. And number 4, utilize the AV engines, though they have drawbacks. It helps get that first opinion on whether that file is bad or not. And it's good to have a mixture of AV engines, a mixture of technology that does it based on signature versus machine learning based algorithms. Number 5, sanitize the file, meaning if there is a JavaScript in a PDF, there is no reason an application needs JavaScript in a PDF, right? So sanitize those malicious embedded objects in the file. Number 6, randomize the file name. Anything that the user sends in is untrusted. It's not going to be easy always, but you could start with something like a hash of the file name, for example. And then return a generic error. We don't want to say to the attacker, hey, you uploaded a PDF and 3 of my engines detected it's bad. We'll keep it straight and say, this file is not accepted by the system. And then number 8 is very important. Whatever the submission-based analysis system does is a primary check. You'd want a secondary check where you triage, you have your reverse engineering and malware analysis team look at the file, decompile it, and do the second level of analysis and investigation. Now to the scaling part. So if you tie this back to the question I had initially, right? How recent should the analysis results be for us to allow a file? So if you look at the web applications today, a lot of them accept files through APIs. There are web services where somebody could write a bot to upload a file, and typically there are no restrictions, right? Somebody could upload 30 files in a second, for example. So there is high frequency of file uploads, and the submission-based analysis needs to churn out an result in a defined time, right? Again, that could depend on what your application flow is. If you want to have asynchronous flow, allow your user or client to do something else while this is working. There are popular email systems that do that, right? Gmail, for example, allows the user to do something else while the file is being uploaded. So that's something you could think about. So to her point, 24 hours could probably mean or make sense to you depending on your use case. But what's harder is handling this high frequency, right? I mean, you have 86,400 seconds in a day, and let's say you're getting 100K files. That's about one file that you'll have to churn out from the analysis every second, right? And if you have 10 minutes for the scan time, it's going to mean 10 minutes is 600 seconds. So it means that you would probably want to have 600 VMs working in parallel to churn out 100K files in 1 second, which is huge, right? So we have to think about whether it makes sense to scale horizontally, or do you scale vertically? Have more CPU cores, for example, have processing in different servers so that it doesn't fail. And also we have to think about queue management. How do you place the files in a queue when it comes through? Whether it will be based on the file size, the priority, and whatnot. So these are just the considerations that you would want to take. There is no one size fits all, like I said. But this would be the top considerations as you try to scale this automated analysis system and make it work for your business use case. So streaming is very hard to analyze, right? You need the entire file. So you would have to stream it to a central location, club it together as a file, and then send that file for analysis. Otherwise, we are looking at bits and pieces of information, and the submission analysis system or malware processing technique is probably going to miss a different factor. Yeah, I think irrespective of whether it's HTTP or other protocols like SFTP, right? We need to look at what are the different delivery methods, and then try to see the file as a whole, and then analyze the file as a whole before accepting it. So it would apply for SFTP. So it depends on the user base, right? So if it's an internet-facing application, and if it's allowing a user to sign up based on email, basically anyone in the world can do that, right? If you have your Gmail account, he can sign in, create an account. He's still authenticated and authorized user, but the risk level is higher. So you'd want to define who the user base is, and then put in a set of controls based on that. And that could vary depending on, okay, I'm allowing only one file to be uploaded by this user for the entire life cycle, right? Or if he's based out of a very risky region of the world, I would want to scan a file. So it actually varies. Right. Yeah, that's perfect example, right? In the container world, you can spin up on demand, run a file, and then throw it away if you don't want. That's going to be very useful. I think that will be very useful, but you would want to keep in mind that spinning up that VM and running that analysis will probably take you, let's say, 10 minutes. You would want to see how the users would react or what the users would do in that meantime. All right, I'm going to be here if you want to talk to or chat about anything. Otherwise, thanks for taking the time. It was good talking to you.